Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. What if an AI could realize, I don't know enough about this, unquote, not hallucinate, not guess, not wait for retraining, but actually decide to learn? Today, we explore the visionary paper titled A Theoretical Framework for Self-Directed Knowledge Acquisition in Agentic Large Language Models by Anthony Maio. This isn't just about improving LLMs, it's about giving them curiosity, autonomy, and memory without changing their weights. LLMs today are frozen in time. They suffer from knowledge cutoffs. They hallucinate when unsure, and updating them, that means expensive retraining. Anthony Maio proposes something radical. What if we never change the model's parameters again, but instead let it expand knowledge externally? Learning becomes structured memory growth, not weight updates. At the center of this framework is the curiosity service. This module detects knowledge gaps using token entropy, hallucination detection, intrinsic curiosity models inspired by Pathak et al. If uncertainty crosses thresholds like entropy greater than 2.0 or hallucination score greater than zero point 0.5, the system flags it as a point in the unknown. It even computes a composite priority score using weighted signals. Not just, I don't know, but this is important enough to learn. Flagged concepts move into something beautifully named the subconscious mind, a temporary queue with TTL rules, prioritization. Then, during downtime, the system activates agentic web exploration. Using frameworks like React style reasoning, the LLM forms search queries, selects tools, retrieves documents. It becomes an autonomous researcher. Here's where it gets serious. The system does not trust the internet blindly. It passes information through a multi stage validation pipeline. Stage 1, fact checking ensembles by end target 85 to 90% accuracy. Stage 2, bias detection, target greater than 70%. Stage 3, source credibility, some minimum trust score greater than 0.7 from at least two sources. Only then, the data admissibility rules engine checks bias score less than zero point 0.3, factual confidence greater than 0.85, ethical and copyright compliance. If it passes, it earns admission into long-term memory. Instead of retraining, knowledge is stored in a graph-ragged long-term memory. On page 6, the knowledge graph schema shows entities like concept, fact, entity instance, source a document, with relationships like relate to, derived from, contradicts. This memory supports semantic search, multi-hop reasoning, versioning, conflict resolution. The LLM doesn't rewrite itself. It queries structured knowledge. Zero parametric forgetting. On page 8, the paper positions itself in the autonomy parametric modification landscape. Traditional continual learning modifies weights. LoRa modifies subsets. Rehearsal methods replay data. This framework, high autonomy, zero weight modification. It occupies a unique quadrant. But this is a roadmap, not a deployed system. The paper openly addresses challenges, scalability and compute cost, validation reliability, risk of bias amplification, self-deception loops, knowledge obsolescence, governance and oversight. It proposes evaluation KPIs like one score greater than 0.75, knowledge graph integration success greater than 95%, 1050 new validated concepts per hour, and raises deep questions. Does retrieval equal understanding? Can AI discover unknown unknowns? Who governs autonomous knowledge growth? Anthony Maio's framework shifts the paradigm from training bigger models to building better learners, from parametric intelligence to epistemic autonomy. And perhaps the future of AI isn't about changing the brain, it's about teaching it how to grow. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.